Good morning. Thanks very much for showing up so early. You're at the hidden keynote of PDC. It's 8:30, so it has to be a keynote.
Yeah, it is 8:30 after all. That's why we got up so early.
That's the only reason. Okay. So welcome to Contract Checking and Automated Test Generation with PEX. And in the spirit of it being the last day, you actually get a 2-for-1 sale. So there's going to be 2 tools in this one talk. I'm going to talk about code contracts for .NET. My name is Mike Barnett. I'm from Microsoft Research in the area Research and Software Engineering. And I've worked for several years on a project called Spec Sharp, which you may have heard about, which was a research language. It was a superset of C# 2.0. And it offered some advanced verification features. And one of the exciting things about doing work like that is now we've been able to take some of the things we learned in static verification and runtime verification, and we're moving them into the tools you're going to see in .NET 4.0, and I'll talk a lot more about that in the rest of the talk.
I will talk about automated test generation with PEX. My name is Nicola Tillman. I'm also with Microsoft Research, and I've been with Microsoft Research since 7 years. In the beginning, I worked on tools to model software systems. We wrote compilers to execute these models, and we wrote tools to analyze the models and to generate test cases from them. That's a very good idea, widely used, but then I realized that one can use these techniques not only to analyze models and to test models, but we can analyze the program itself. And the result of that is PEX. It's a tool that looks at the structure of the program code in order to come up with test cases that actually matter for your code. It looks at all the branches and the statements in your code. And I will show that later in the second half of this talk. So don't leave if you're not interested in contracts. The second half is about PEX.
Well, it's hard to believe that anybody wouldn't be interested in contracts.
Sorry, Mike.
Especially given that we're announcing today. So one thing we learned in doing Spec Sharp is that it's very difficult to produce a new language that's of broad use. And the great thing about .NET is that if you provide a library solution instead of a language solution, then immediately everybody using any language in .NET can take advantage of it. So what we're going to be shipping in .NET 4.0 is a contract library that will give you a language-independent way to express contracts. In addition, once you've expressed those contracts, there will be some tools coming out on DevLabs which will take advantage of those contracts. And that's what I'm going to be spending most of my time on today, is showing you the tools that make use of those contracts and give you important ways to help you make sure your code is correct and reliable.
So Mike, you say the tools will come out on DevLabs?
Actually, they're not available on DevLabs yet. There is a pre-release on the Microsoft Research download site that's available right now. That's for unfortunately, it's only for non-commercial use, but you can use it with Visual Studio 2008 today. So while you're sitting there, feel free to go ahead and download it and play with it and play along with what we're doing. So I'm already suffering caffeine withdrawal because I was over there at the Starbucks this morning and their computer went down. And they had to close the whole shop. And you know, that happens all too often. And I'm sure this has happened to you. It happens because you look at a piece of code and you don't always know what to do about it, right? So here's a piece of code that you've written, I'm sure, in some form or another, where you call some method and you want to use the result of the method. And you're wondering, are there anything that could go wrong with this code? What's going to happen at runtime? How can I look at this code and know if there's any problems with it?
Maybe you need a null check.
Oh yeah, I hadn't thought about that. That's right. So it is true that that string really could be the value null. So maybe I gave the wrong argument to get description, and what I get back is a null value, and now S is null, and I'm going to get a runtime error when I try to dereference S. In fact, I'm not even sure what are the right values of I to be passing to that method.
But Mike, it's very easy. You just go to the definition, and then, it tells you get the string, and you give it an integer.
Well, that helps. I'm happy that the compiler gives me this kind of correctness, right? I know that if I pass it an integer and I get back a string, at least I won't get any type errors at runtime. But that's really not enough, because I need to know that I get a non-null string back. Otherwise, I'm going to have to do something more important in that code up there.
Okay, I see what you mean, but so there's more. Somebody actually wrote documentation. So, this tells you everything now, right?
Oh, okay, let me take a look. Wow. All right, that does help a lot. Well, okay, I'm not sure it helps as much as I was hoping it would help. What does the word should mean? I mean, is that like something it would be nice if I did it, or is there going to be a runtime exception if it's not greater than 0?
We should be nice to our software.
Well, we should be, but I also want to know, like for instance, that return comment that says I get back a non-null string. What's the enforcement on that? I mean, how do I know that that really was ever enforced? How do I know that the comment wasn't written a year ago and the code has drifted out of sync with that comment?
What else can we do, Mike?
Well, our proposal is to fix this problem once and for all. So using the contract library that will be available to you in .NET 4.0, you can actually write code contracts in your methods. And those contracts are going to be explicit, formal statements about exactly what the meaning of this method is. So this tells you that it actually is invalid for a client to call that method with a number that's not greater than 0. And it also tells you that there's some enforcement behind returning a non-null value.
So you mean these are not just statements in the code, but it's part of the signature, the documentation that I get when I look it up?
Exactly. The way you have to think about this is, for the moment, suspend worrying about what's going to happen at runtime. Just think of this as somehow that we've extended the signature. So now the signature of this method is not just that it takes an integer, but it takes a positive integer. And the return value is not just a string, a value of type string, but it's a non-null string. And that ... down there is the rest of the code, whatever the method does. I don't care about the implementation. This might even be an abstract method. It might be an interface method where I don't even have any code available to me at all, but at least I still know what the contract is for that code. And what this means is that design by contract is now going to fully meet .NET across all the .NET languages. These contract methods are available inside of the new namespace, system.diagnostic.contracts. In the CTP you have on the hard drive that you've all been given, the name of the class is actually a little bit different. It's called code contract, but in the final release it will be contract, and I'm going to use that for the rest of the talk. Okay, well, why would you do all this? I mean, I hope that some of this is things you already believe in. I mean, our idea is that contracts give you a way to encode the design decisions that have always been in your head. When you write code, you always have these extra ideas that just there's never been a way to express it other than comments or informal documentation. And it encodes the kinds of decisions that are needed as code evolves in the future. It's one thing to write the code. It's another thing to come back a year later. It's another thing to come back and have to do a subclass and try to remember what it was that the behavior of the superclass needed to ensure and guarantee, so that you make sure you don't break clients' expectations if they're still using, if their view of it is as of the superclass. Because of the way that the contracts are encoded, they're executable. And I'm going to show you tools that take advantage of that to actually do runtime checking of those contracts. And we have some advanced tools coming out of Microsoft Research that do static checking, so an advanced checking. The same way a grammar checker does a more advanced check of your document than a spell checker does, the static checking is going to give you an ability to look at the code at compile time and rule out entire classes of runtime errors so that you don't suffer having to worry about them, and maybe you'll never have to test again.
I don't think so, Mike.
Well,
but you can use contracts for testing too, right?
That would be great, because it is true that you can never actually get rid of the need for testing. And so it's important to have contracts work well with testing. And you're going to see that when Nikolai gets his chance up here.
Thank you.
All right, well, enough of that. Let's quickly go to a demo, because that's always more fun. Got it up there? Great. So here's the kind of class I'm sure you've all written a million times, right? I want to have a simple numeric data type rational that's not available, so I need to implement it. And it's just going to hold on to two integers that represent the numerator and the denominator. And I have a simple constructor that takes two integers and stuffs them in the fields. And now I have a method that returns an integer by truncating, by dividing, doing integer division on the numerator and denominator. And sure enough, as we talked about on the earlier slide, if I build that, the compiler is happy. Right? It doesn't know that there could be any possible problem here. And I'm sure you've already spotted what is the possible problem with the code, just as it's been written. Right? Nobody's going to shout it out? All right. There we go. Everybody knows the division by 0 is going to be a problem. So what can we do about that? Well, when you install contracts, you will get a VS add-in so that in any project in the VS system, you'll have an extra pane on your property windows for code contracts. And what you can do with that is you can turn on runtime checking of those contracts, and you can turn on our static checker.
So I need to download the preview if I want to have these options?
Currently, you'll have to download the preview and use this with Inside 2008.
So that's a Microsoft Research download preview, pre-preview.
It's a pre-preview from
Okay.
Microsoft Research. As soon as it's available on Dev Labs, you'll be able to use it with Visual Studio 2010. So let's go ahead and turn on those options. The question was, does it work in Visual Studio 2005? Yes, it would work inside Visual Studio 2005 as well. Okay, so now that I've turned on those options, let me build again. Why am I building? I said it was a static checker that looks at it at compile time.
Yeah, you haven't written any contracts yet, Mike. What are we checking?
I don't know. Let's find out if the tool actually finds anything, even though there's no contracts in there. It turns out that there's contracts even if you don't know them. Everybody spotted the divide by zero. That's actually a contract, right? The CLR runtime says you should not divide by zero. If you do, you'll get a runtime error. Right. So I'm turned on the checking, and now we see that indeed the tool noticed after it built. The reason I had to build first was because since it's language independent, all of our analysis works at the IL level. The IL is the binary that's generated by any of the .NET compilers. So the compiler ran, it generated the binary. We look at the binary, and we're able to find out that there's a possible division by zero without even having to execute the code. So now we have to fix that. Well, it seems clear that we probably shouldn't allow arbitrary clients that can create a rational to pass in a zero value. So I'm going to add my first explicit contract and not just have the implicit contracts. And I'm going to add a call to requires. And in fact, I think I'll make it something stronger. I think I'll think ahead and maybe do a little designing here and think, yeah, if I'm going to have a negative rational, I really don't want the denominator to hold the negative. I'll put always that in the numerator. So I'll just actually tell clients that they have to pass me a positive number as the denominator here.
So what's the difference to writing if not then so argument exception?
The difference is that this is actually part of the signature now. Using our tools, any client calling this method is going to be able to see that they should not be passing a non-positive value as D. And that's really important because it means that a client doesn't have to guess, they don't have to worry, they just will automatically get that as part of calling the method. Okay, so now let's build again. That should fix our divide by zero error, right? There's no way to create a rational that has a zero denominator. But the static checker still notices that there could be a problem here. How could there possibly be a problem? If I'm not allowing a rational to be created with a zero denominator, how could it ever be that we get a zero denominator?
Mike, I think it was, the fields were protected and your class isn't sealed.
Exactly. The static checker is thinking about all possible scenarios as this code evolves. So one thing that could come along is somebody could declare a subtype of rational. They could add new operations. Those operations are certainly free to store a zero in that denominator. So it's not the case that merely protecting the entry point to the creation is going to prevent the division by zero error. What I really need is a property of the type as a whole. I want to know that whenever I have a rational in my hand, that denominator is not zero.
Just add a check at the end of each method.
I could add a check at the end of each method in this class, but what am I going to do about subtypes? I don't even know if the subtypes exist yet. I don't know where they are. It's a public class. People can come along. So what I really need is a way to talk about the type as a whole and its internal representation and how to protect that against future code evolution. And that's a concept called object invariant. So this is a way to define internally for me as an implementer how an object, when an object is in its good state. And so what I'm going to do is I'm going to say that an instance of class rational is in a good state if its denominator is greater than zero. This is now binding at all exits of constructors and in all exits of public methods in this class and in all of its subtypes that might eventually come along.
So you mean I have to add a call now to this method in every method of my class?
No, that would do no better than doing a standard, just your own coding inside of each method. The point is that our tools are going to treat this and for the runtime checking, actually inject a check for it at the end of every public method and at the end of the constructors. All right, so now let's build one more time. And sure enough, we see that division by 0 does not need a runtime check. Right? We're now guaranteed that we're never going to have to worry about that denominator being 0. And we can just go ahead and implement that code as efficiently as we want without having to do lots of error checking every single time. Okay, so I think that's it.
Do you want to add another message to this class?
This isn't enough methods? You need more methods in this?
Yeah, this version type doesn't do anything.
Oh, yeah, that's true. I can't do anything except create one and return an integer. All right, let's add another method.
I think you can do better, yeah.
All right. Let's add a method that adds 2 rationals. And it makes sense here. I might as well go ahead and add 2 explicit contracts. It doesn't make any sense to allow clients to pass in null rational values. So we'll put in a precondition there that says that A and B can't be null. And then I'll go ahead and I'll compute a new numerator, I'll compute a new denominator, and I'll return a brand new rational with that numerator and that denominator. So I want to be careful. Let's build one more time, make sure that there's no possible errors that can come about through doing this.
Looks pretty good.
Seems like it should be pretty bulletproof. Uh-oh. Whoa.
Control Z.
Thank you. Right? We actually get 2 warnings here. That's because it's telling me that a precondition has been violated, and it's telling me where that precondition has been violated. So first, let's double-click on the precondition. It's saying that somebody is trying to call this constructor with a value which is not guaranteed to be a positive number. And if I click on the other error in the error list, it tells me this is actually the piece of code that is trying to create a rational that where the denominator is not a positive number. And that, I don't get it.
You don't get it?
I have two positive numbers right here, and I'm multiplying them. How can I possibly get a non-positive number? I wish I knew, yeah.
You wish what?
I wish I knew what values could possibly do that, because I don't understand.
Right, so all we get here so far are warnings. I think I can help you with values. So I already installed PEX on this machine. So what I can do now is I can point to a method and let PEX explore the code and come up with values that trigger different cases. Let's see if PEX can find this division error or the contract violation. So PEX is exploring the code, and it comes back with a table. And in this table, we see that a precondition can indeed fail. I think that's the error you saw.
Yeah.
And then PEX also gives us values, and I think that's what you were missing.
PEX actually was able to figure out exactly which values violate that contract?
Yes, we use a constraint solver to come up with values. And Mike, I think here we have 2 really big denominators. Maybe you get an integer overflow.
Yeah, I should have thought of that. That's right. Okay. Okay, well, we're kind of running out of time for the demo. So let me just fix it really quickly by just saying that if...
I can test it later. It's okay.
Oh, okay. Well, as long as there's testing, I guess I don't have to worry about anything then. So for now, I'll just throw an overflow exception if that happens. Do some proactive testing. Let me build one more time and make sure that the static checker at this point is happy with it. And sure enough, static checker knows that that was the problem, and there's code now is clean. Oh, that's great. Oh, that's beautiful. Okay, so what I hope you picked up from that demo, if it wasn't clear enough already, is that you can take contracts and you can do lots of things with them. One thing is that PEX works perfectly with contracts natively. So it figures out which test cases might violate a contract. It shows that to you. You're going to see a lot more about PEX in a few minutes. You saw the static checker, which actually looks at your code before you ever run it, finds things as early as possible. We all know that finding bugs early is the way to make cost-effective changes to your code. The later you wait to find a bug, the more expensive it's going to be to fix it. There are cases where static checking is not able to do everything. No static checker is perfect. Then it's important to also have runtime checking. In fact, PEX takes advantage of the runtime checking code that is generated from those contracts. And what our tools currently aren't showing you, but I think you can well imagine, is that you can generate documentation, even IntelliSense hints, from the contracts that would show it to programmers in the IDE. So the kinds of contracts we give you the ability to write, you saw method preconditions. Those are requires calls. A requires call is something that must be true at method entry. It's a contract on the caller of the method. It's telling the caller that this is what you must guarantee before you call me. And if you don't guarantee these conditions, you have no business calling this method. The other side of a contract is always what you're going to provide. So an insurer's contract says what must be true at the method exit. It's a guarantee to the client about what behavior they can expect when the method returns to them. What you didn't see in the demo is we also have a way to have a contract on exceptional exits. So you can say if calling this method ends up generating an exception of this particular type, then here's what you know about the state of the object. For instance, if a socket closed exception gets thrown, then you know the socket's back in its reset state. And as you saw, there are ways to specify invariants. So you can talk about what must be true across all methods of the class, including subtypes, including implementations of abstract types like interfaces. There's other types of contracts. Once you download the tool and use it and look at the documentation, you'll see there's lots of other things in there. The kinds of things you can put in a contract, well, these are just static library calls. It's in the programming language you're writing. That means you can put any Boolean expression as an argument to that call. That means you get all of the benefits of the IDE that you're using, which is Visual Studio, of course, to give you IntelliSense and completion, type checking, all of those things. You can even call methods inside of those contracts. We have special ways for you to talk about the return value that comes back from a method, so you can give guarantees about that in a post condition in an insurer's contract. And in an insurer's contract, you often want to talk about the difference between the state at the entry to the method and the state at the end of the method. And so you're able to use, we have a way to encode talking in an insurer's contract about the old value, the value something had at the beginning of the method. Okay. So in more depth, this is what it looks like. Here's a add method for some kind of collection type. It takes an object. We've decided that we don't want callers to add null values to the collection, so we have a requires that the value is not null. That's in red. In the green, you're seeing the insurer's contracts. The first one is saying that the count property on this class, the value of that count property when the method exits, should be 1 greater than the value of that count property at the beginning of the method entry. And it's also telling you that the value that comes back, that's returned by this method, is whatever the old value of count was. This is pretty much the contract for add an array list, right? And then there's the code that does the actual work. Here it's pretty simple, but of course, in your real code, it's probably a lot more complicated. So the main feature of contracts is that they're declarative. They're not telling you at every single program point what has to be true. It's a declarative statement to clients about what the input-output behavior of the method is. So this is why I said earlier, you have to get away from thinking about contracts as something necessarily executable. This is, of course, the wrong place in the code to be testing a post condition, right? It's meaningless to have the insurers before the code. So it's a declarative statement. And you use the tools that come along with contracts to do the right thing if you want runtime checking of those contracts to put those checks at the method exit points. As I said earlier, the arguments to the methods are just expressions in your language. And so that is in whatever, in this case, it happens to be C#. It could be VB, F#, any of the .NET languages. You get all the benefits of your IDE there. And we have those special encodings for talking about the value that comes back and being able to talk about pre-state values at method entry. And you also saw that you can write object invariants. Let me go into this a little more depth on the runtime checking. Whoops, wrong button. There we go. So in fact, here's a little implementation I wrote of ArrayList. It's probably not as good as the real one, I would think. In fact, maybe we'll find out if it's as good as the real one.
I think you just copied it, didn't you?
No, I decided, if I was going to show it publicly, I probably should scrub it and do some coding of my own. So this is probably not as good an implementation. But, it does the standard thing. It keeps an internal array. It's got an index into that array. And I have contracts on lots of methods. I have all the different methods here. and here's the add method. And you see pretty much the same contracts we were seeing on the slide. I've got a few extra ones. So this is the one that says that the number of elements in the array list have gone up by 1 by adding something to it. This tells me that the value that comes back is a valid index into the array list, right? So the result is at least 0, and it's smaller than the value of the count property at the end of the method. And there's an indexer defined on this method, and it turns out that the contract of add tells you that if you index the array list at that index after you've added an object, in fact, you will get back the same value that you just added to the collection. I've then gone ahead and defined a subtype, and the subtype has an override for the add method. And I'm a pretty lazy programmer, so I'm just going to call the base class to do all the heavy lifting, and I've decided that I think a much better return value is -1. And that's probably why I'm in research and not in the product groups, because I don't think you'd get away with that over there. But let's see what happens now, because I went ahead and wrote a...
So there's no contract in that method, right? So -1 is okay, I guess.
Well, it seems like it should be okay. I mean, there's nothing here that says what I have to return. It just says that it's, I'm going to go ahead and return -1. And I'm going to have a little test class here. I wrote my own test code.
So we can do that with PEX, right, Mike? We can generate tests.
You can actually generate tests like this. I don't have to actually write these by hand.
Yeah, next time you do this demo, you have to use PEX.
Oh, man, I'm going to come talk to you after this talk. That would be great. Well, I wish I'd known about that, but I went ahead and wrote one by hand. So I'm going to create an instance of the subtype. I'm going to call some methods on it. In fact, I'm going to call that add method and see what happens. So let's just run this code. Wow, somehow that contract actually got populated down onto the subtype. So here we are with the add method being called on the subtype, and yet the post condition was checked at runtime, and it was found that I returned a bad number.
Cool.
That's pretty cool.
So,
whoa, that's very cool.
well, what is this rewriter methods over there? I didn't write that. You didn't write that.
Good point. So the tools take care of injecting the contracts at all the right points, and I'm going to show that. In fact, why don't we just show that right now, how that's done. So how did that actually happen? How did that post condition get put into the subclass and then checked? And where did that method come from that was actually in the stack frame? Well, the truth is you don't really want contracts in all of your code. Probably when you do a release build and you send code out to be executed in the field, by that time you've used the static tools, you've used the runtime checking. They better have used PEX a whole lot. You get a very good feeling that their code is correct. You don't want to pay that runtime overhead. So all of these methods that I've shown you so far are actually conditionally defined. And if you don't define the symbol that causes them to be compiled, then when you do your release build, you get exactly what you want. You get only the implementation code and not any of the contract checking.
So even the preconditions are gone?
If the preconditions are written in this form, then they're gone. If you decide because of your coding standards in your team that you want all of your public entry points to have the contracts checked at entry, then there are other methods in the contract library that allow you to write contracts that then will be in the release build.
So my code will run faster without the contracts?
You will not have to pay the penalty for checking contracts that you don't need to check at runtime. Like I said, so if you have contracts that you want checked even in release builds, then there's a way to put them in there. But what I'm showing here is a way to also make sure that you don't pay the penalty when you don't want to. When you do define that symbol, then the contracts are there. The compiler doesn't know anything about these. They're just method calls to some library. It generates the IL, the binary that those method calls represent, and that assembly is just sitting there. This assembly is not executable as is. Notice that the post conditions, the insurer's contracts, are sitting there before the body of the method. And then our tools come along, look at the binary, figure out which parts of the insurer's contracts represent old values from the pre-state, inject code at the beginning of the method to store those away, check the preconditions, run the code, check the post conditions, check the object invariant if you've defined one, and does this for inheritance when you have a subtype, as you saw in the demo, and make sure that your contracts are all formed correctly. Let me say a few more words about the static checking. So the runtime checking is great. It guarantees that anything you write in a contract can be checked. The limitation with anything that happens at runtime is it's limited to the code paths that actually get exercised when you execute your code. The static checker, however, analyzes all possible execution paths. It uses a advanced technique called abstract interpretation to understand all possible paths, all possible data values that can flow through your program. And this is the way to catch errors at the earliest, because it means you do it even before you run tests or run your code. As you saw in the demo, it tends to guide your development. It finds some violation of either an implicit contract or an explicit contract, and you start adding contracts to remove those problems, and then that makes you realize that there's some further problem, and it moves you through your code and helps you propagate these implicit assumptions that you have in your head when you program and makes them explicit. And as you saw in the demo, it's not only the explicit contracts, but it also covers the implicit language runtime contracts such as dereferencing null, array index bound errors, and arithmetic exceptions. So now that you're all excited and you all want to use contracts, what's going to happen when you build your code with contracts and you provide your assemblies to your clients? Your customers should get the same benefit from using contracts that you did. And here you are, you've got your sources, you've used contracts, you've written them all through your code, you've given them this release assembly, and as I showed you, that release assembly does not contain all of the contracts that you wrote in the code. So our tools also generate a reference assembly. A reference assembly is an assembly that has only the contracts and none of the code, and our tools are able to glue those back together. So the very end customers that are running your code, they only run the release assembly that's there on the left. But your customers that you want to make sure that they can check their code against your contracts so that they're using your code correctly, they're able to use our tools with the reference assembly and your release assembly and still get the benefit of all the contract checking. And it shouldn't be any surprise how we do that, since I showed you we can do all this fancy binary rewriting. If we take that assembly that has all the contracts in it, the reference assembly is one where we just preserve the contracts and throw away the code. This works even for interfaces. Here's a simple interface that has a method. There's no place to put the contract. Interface methods can't have bodies. But we allow you to write the contract in a class whose existence is there only to hold the contract, use some attributes to link the two up, and now our tools can recognize that as the contract for that interface, and all of the classes implementing the interface will inherit that contract. So what we're going to provide for you is a way to have contracts without any restrictions on what you can express. Anything that you can talk about your code, the fact that a method can only be called if the object is in a certain state, that it guarantees that only certain exceptions are thrown, that the return values lie within some range, all of that you can write using the contract library. These contracts are being used today inside the base class libraries. So in the .NET 4.0 framework, there will be code that actually has had contracts added to it, and the library itself is a core component of .NET 4.0. And the crucial thing is that these contracts are exactly the same contracts that can be used for all of these different purposes. So you're not having to write things in multiple places and have to worry about them getting out of sync. You write the contract once, and it's used for runtime checking, static checking, documentation generation, and whatever other downstream tools, like PECs, might come along and want to look at them.
Okay, so now we know all about contracts, and it's a great tool to make our code more robust, and you get all the benefits. But I think sooner or later, you really want to run your code. You want to see test cases that run so that you see in action that your program does the right thing, right? And PECs is a tool that helps you to get those test cases. You can download PECs right now. PECs is a DevLabs project. DevLabs is a site on MSDN where incubation projects are hosted. You can get it there for Visual Studio 2010 CTP, the version you have on your hard disks. And there's also a version for Visual Studio 2008, which comes under the Microsoft Research license. Okay, so much for the advertisement. Back to testing. So we all want to see test cases, but in reality, well, we don't really have as many tests as we should, right? And why is that? it's just hard to write all the tests. You have to set up the test project, you have to write all the different cases down. And even then, how do you know you've written all the cases? It's really easy to miss some. And then you have this test suite, and then a customer comes in, wants a change, and suddenly all your tests are outdated. And finally, you probably don't write code in isolation, but you use some other library. And so when you write your tests, do you know what that library is doing? Do you really know what that library is doing? So PEX is a tool that helps us with all these issues. And I will show you in a couple of demos how it works. So in the first demo, I want to revisit the rational example. And remember that I'd run PEX already, and then we used our brain to figure out it was probably an integer overflow. I want to debug the issue. I want to see more about it instead of just thinking what might have happened. So I just removed the error, the fix of the error, and now I run PEX again. So as before, PEX is available through a button in the context menu. And now PEX explores the program, looks at all the different branches in the code in order to come up with, first of all, this table that you have seen already. And I can just look at the table and think, but I can also click on an entry, and then I get a details view. For example, here I clicked on an error, and then the details view shows me the stack trace that is associated with the error, because PEX actually ran the code with the inputs, and it got the stack trace of the error. And I have different buttons I can use. So I can, for example, send a mail or file a work item for someone else if I don't want to fix the error. I'm just a manager. I'm not fixing bugs. But let's face it, I'm not the manager. I am fixing bugs. So here's something else we can do. There's a save test button. What does that do? It's similar to the wizard in Visual Studio in that it tells you here it will create a test project. But in the test project, it will plug in a test case that does something really targeted. It's the test case I've seen in the table that will reproduce the error. So I just apply, and now the test project is being created. Now I can see in the Solution Explorer that indeed there's a new test project which didn't exist before. And I have the test generated here, which has all the right values in it. So if I go to the code position where the failure occurred, I can now set a breakpoint here. And then in PEX, I can click on the debug button. This will now go into the debugger. And I should break at the breakpoint that I set. And then I can step through the different pieces of the code. So now we are live in the debugger. And we can look at the stack trace. Where are we currently? We are currently in the first constructor call. So this is not where the bug occurs. I press F5 to continue. Where are we now? Now it's actually adding. We're at the end of the add method. And now I can look at the live values that we just thought about before and looked in the table. I can actually debug this, Mike.
That's amazing. You can really come in and just
look
at every little piece of data. That's very good.
So what I just showed you is it's very easy to get started. You just right-click in the code, point on a method, and PEX will explore it, bring it to life. And as a result, you get test cases. And all you had to do is click. And so there are all these different components to it. It's a whole new environment to test code. You get the table to look at. You can file work items and emails right there from the bug. Or you can save it and debug it. Okay, next demo. So now we have mastered rational numbers, right? That wasn't so difficult. I want to do more. So let's say I signed up to become a developer for the NHibernate project. That's an open source project that provides database connections. So somebody told me if I want to be useful, here's a class that I should test. And so this is taken from the real NHibernate source code. It's a type name parser I'm looking at here. internally, it stores its state in a text reader. And then there are methods I can see which parse little pieces of the input. And let me look through the code. There are actually a bunch of such methods. They have lots of cases in them. There are loops. And so I'm looking at this code for the first time, and I'm just a bit overwhelmed by all the cases. I don't really understand what it's doing.
I think you'd understand it better if they put contracts in it.
That's true, but unfortunately, Mike, they didn't.
That's sad. I guess you're going to maybe be able to do something with PEX to help out.
Yeah, that's why we are here. So let's see what PEX can do. So again, I can just right-click into the main function here and run PEX on it. And now PEX, again, will explore the code, look at all the branches, use a constraint solver to come up with interesting values. And as before, we see a table. Now it's bigger, it has more values. We have, in fact, now 3 different inputs that this function takes. And sometimes an exception is thrown, sometimes not. So I could, again, click on a row. So here's just some inputs look a bit weird. I should probably debug them, but I don't want to debug these things right now. I just want to understand the code a bit. Wouldn't it be nice if we could I just wonder, how could I reach, for example, this line? It seems to be a funny exception condition. I want to test just for that line. How do I do that? So what I can do now with PEX, instead of just debugging issues that PEX finds or test cases that PEX gives you, we can select all of the test cases with Control A, and then I can also press the Save button. And this will now, again, create a test project, but not with just one test case in it, but with the entire table written out as test code. So what I get is this file, this automatically generated file, full of test cases. And you can see it's a bunch of code. Let's look at one of these test cases. So each test case is tagged with a test method attribute, which says it's a Visual Studio team test unit test. And it's generated by PEX. So this is generated code. Don't change it. PEX controls it. And how does the test case look like? Well, it always initializes some data, creates objects, and then it calls a function under test with some values, and it stores a result. And then PEX actually ran the code with these inputs, and it looked at what the result was today. And the result was not null. PEX added an assertion for that. And PEX looked at all the properties and added assertions for the properties. This is what the type property returned today when we ran the implementation. So when I take this test suite, then today it should pass because PEX generated it today. And when I make a code change, then maybe this test suite is able to detect the code change. So let's see. All of the tests show up in the Visual Studio test view, so it's fully integrated with the unit test framework. So I can now select all of them and run them in Visual Studio. And just to check that indeed all the generated test cases represent real behavior, they all pass. So all the generated assertions indeed are true. As you can see, they pass. And now when I make a code change, let me go back to the implementation code. Here. Let's say I make a code change, arbitrary change somewhere. Then is this a breaking change? It should be. But we can use now this test suite to check whether it really changed the behavior. Can we? So I run the test suite again. Oh, and indeed, many assertions failed. So this test suite seems to have potential to find code changes. Let me undo my obviously not so good change. And what I can now also do in Visual Studio is I can visualize code coverage. So just ran the fixed code again. And now I should be able to look at the code coverage that Visual Studio can measure. And so let me expand this view that Visual Studio provides me. And first of all, what we see here are numbers. And what we see here is, this is the type that I was analyzing. So I right-clicked on a method in that type, and we got full coverage, 100%. All those branches, so these are the coverage numbers. And
Whoa, that,
so that means just visually, everything is nicely colored in a friendly way. All the little cases that I didn't even understand. Okay, so it's good at finding regression errors, but remember what I really wanted is I wanted to know how I can reach a statement, because I want to understand what this piece of code is good for. So what I can do now is simply set a breakpoint here, and then instead of running the tests, I can debug them. And then as before in the rational demo, PEX will stop, or Visual Studio, the debugger, will stop at this statement because we have a test case for it. We have code coverage. And now I can look which test input actually triggered this line of code. Right? Okay. So I continue my investigation. I understand a little bit more about what the code is supposed to do. And so around this check, it is doing something with an assembly name, and it's checking for commas, and then bad things happen. So over time, I developed a theory about how this code works. And so you might have done this too. So when I think what the code is supposed to do, it's a good idea to write it down as an assertion, which is a form of contract. Right, Mike?
it is. In fact, it's an internal contract that talks about something at this point, because we don't know that the clients really
at this point,
know about this.
It's an internal idea that I have, that in the end, when everything was passed successfully, then I shouldn't get a comma as the assembly name. But is it really true? And again, I can just ask PEX. And now it's a new branch in the code that I added. An assertion is similar to an if statement. If, not condition, then throw. And so PEX will try to violate the assertion, come up with a value that shows that it's wrong. And indeed, that's what it does. So it finds a test input which fails the assertion. So this is a bold line. So for some reason, it seems that there's a concept of a default which has a comma, and then that is used. So I can use this feedback to improve my knowledge about the code, write more assertions. PEX will check them and give me counterexamples if it can find them. Okay. So what you've just seen is that by just pressing some buttons, I can actually get a pretty comprehensive test suite. Not just individual tests, but an entire test suite. And it achieves very high code coverage. Here it didn't get better, 100%. And so PEX also tries to find errors in your program. It doesn't just give high coverage, but it finds errors, different kinds of errors. PEX can find exceptions when an instruction can throw an exception, like the division error. PEX can also find contract violations. So if you write assertions and contracts, PEX can leverage them to try to check whether your program not only doesn't crash, but whether it's also doing the right thing. So we got a test suite, and it integrates with Visual Studio Team Test. If you're already using that infrastructure, it's fitting in there very nicely. You can keep writing tests as you always did. You can keep using them, and in addition, use PEX to generate even more tests, and they all can live together. And the test suite that PEX generated was rather small, considering the code size. We only needed 30 test cases to cover all the branches and the statements in the code. And each of the tests was also rather small. So it wasn't a huge randomly generated test, but they were very targeted small tests. They are fast running. So you can use them in the future to look for breaking changes before you check in your new code. Or in other words, you can use it as a build verification test. Okay, so all I did so far really was clicking around a bit, and I got the test suite with high code coverage. I think that was pretty good, but there's more. So sooner or later, you want to write some tests from the outside to say what your code is supposed to do. So you can use assertions to say from the inside what your code is supposed to do, but sometimes you want to do it from the client perspective, from the outside. And so in the past, what you did is you wrote tests. or you should have written tests. And so all tests look like this one. They set up some data, then you perform an operation, and then you should assert the outcome. So here I take a rational number, add 0 to it, and then the result should be the same. Now notice that, in fact, here in this test, the value of the rational number doesn't really matter. This is a property that should be true for any rational number, that if we add 0 to it, we get the same number, right? So what we can do now with PECs is a new way of testing. It's not really new. You might have heard of it already under different names. Some people call it data-driven tests or row tests. In PECs, we call it parameterized unit tests because it's really about adding a parameter to a unit test, and then your test makes a statement about all possible inputs for this test. So here the test says that for any rational number that comes in, when we add 0, we get the same value. But so this test by itself isn't executable. It needs values. And that's what PECs does. PECs generates unit tests, as we have seen before, and it cannot just do it from code, but also from these parameterized unit tests. So the generated test always sets up some values in this scenario, and then they call the parameterized test, which then contains the operations and the assertions. So let me show you how this works in practice. And so far we have seen the rational numbers. We have seen some more sophisticated code from the nhibernate project, which had a bit more than 100 basic blocks. Let me show you another real piece of code, which is bigger. I want to show you the .NET resource reader in action, brought to life by PECs. So it's a class that ships with the base class framework in .NET. It takes a stream and chops it up into resources, and then there are parsers for individual resources, for example, for images, for string tables. So it's a lot of code. And I want to walk you through the code, and I want us to think about it. What are all the cases we have to take into account when we want to test this code? So this is a constructor. What does it do? It takes the stream and stores it somewhere, and then the real work happens somewhere else. So then another big piece of code. What does this piece of code do? It's not really important. A lot of initialization work. The first interesting thing happens somewhere in the middle. The code reads an integer from the stream and checks whether it's a magic number or not. Okay, so that's reasonable. Most files should start with a magic number. But the deeper we dig in, the more ugly it gets. Even reading an integer is actually reassembling it from bytes. So I wonder whether any bit gets lost here or whether that's really correct. So if we want to test this code sooner or later, we will have to drill down to these cases if you don't get the coverage you want. Otherwise, you might just overlook cases. Now, how can we leverage PECs here? Let me show this in the demo. Okay. So I've written a very simple parameterized test to begin with. It's not doing anything. I just say I can take a stream and call the constructor. That's kind of how I used PECs before, when I just right-clicked a piece of code and say, look, right? And so let's just see what PECs can do in this simple scenario when I try to explore the code with PECs here. And in fact, PECs is done already. It didn't do much.
It did come up with, it figured out some data value.
Yeah, but I don't think it's so great. It's basically saying when you put in null, then you get an exception. So what happened here? The feedback could be a bit better. But the problem is the stream class is an abstract class. And there are many instances of this class. Some access the real file system. PECs doesn't just use an instance, because maybe it will overwrite files. And I don't want that PECs by accident overwrites your files without me ever telling PECs which file to use. So this scenario didn't really work well. So the idea of parameterized tests is that you have to write down a little scenario of what the code is supposed to do, which methods to call. So here's such a scenario, which is good for the resource reader. It's, again, a parameterized test, which, by the way, we take with our own attribute. And it takes now a byte array. And then it does some sanity checks. We are not interested in null arrays. Then we take a pointer from the array in order to give it to an unmanaged memory stream. It's one of the many stream implementations in the framework, and a rather interesting one. So I chose it here. Then we call the constructor, and then in a loop, read resources. So this loop will actually call move next and current multiple times. So this is really a realistic scenario how we can read resource files. And with this help, let's see what PEX can do now. So invoke PEX. PEX is trying different values. Oh, and we see it creates a table. It's happily doing things. And before going to the details, let me show you this.
Yeah, because in Hibernate, it looked like all those values were pretty random that it just came up with.
Yeah, we will look at the values in a moment. But I want to show you this. So when your code gets bigger, then PEX might take a moment to come up with interesting values. So for example, here, so in fact, it's now already exploring almost 700 basic blocks, and in a moment it will be 1,000. And in this picture, you see the development of code coverage over time. So you saw in the beginning, it was easy to come up with test cases for PEX to hit more branches. And now it's getting a little bit more difficult, but at least PEX is doing it for us. We don't have to look at the code. And every time PEX hits a new branch, it would emit a test case. So every kind of gray line you see here bumps up our coverage and is emitted by PEX as a test case. Okay. So something just happened while I was talking. The graph turned red. What happened? And it's still analyzing. Still graphical flaw. Okay. It's still analyzing. PEX found something that was surprising. It found an overflow exception. Now let me talk a bit about what PEX finds here. So first of all, PEX generates arrays of bytes which have different sizes. So here up to 140 bytes long. Each array contains, as the first 4 bytes, some funny hexadecimal number here. That's the magic number. So PEX went down 4 levels, figured out the magic number, put it in here. And all the other funny values, they are all special values to trigger different branches in the code. And here, with more values to the right, PEX hit an overflow exception. And that's flagged as an error. Now you might notice there are a lot of other exceptions which are not flagged as errors. How is that? So you might have wondered, this test case doesn't have any assertion in it. I'm not really saying what the code is supposed to do, right? But actually, I did a bit of that on the side. So I looked at the documentation, which exceptions are documented. So if I'm a client, I know that, yeah, it can throw an argument null exception. It can throw a bad image format exception. Then I give it a bad file. But what's not documented, and what I didn't specify in this attribute here, is the overflow exception. That's why PEX marks it as an error. And so all of the test cases, again, are stored as text, so you can just debug them. And here you can see that they basically set up different byte arrays. Some are bigger, some are smaller. And yeah, so they contain, yeah, here's a really big one. It's interesting to look at this test case. So it's actually a big byte array, but only few places are set to be non-zero. So PEX figured out what is actually important and what is just the payload, like the image that we are reading. That doesn't matter for testing. What matters is the file designator and so on. Okay. So what you've just seen is that PEX really has a deep code understanding. So PEX does not just guess test inputs. Think about it. What's the probability of hitting the right magic number with a random test generator? Pretty low. And how long does it take to enumerate all possible magic numbers? That wouldn't terminate in time either. And also, PEX doesn't make you write test input generators. I never had to say what kind of inputs, besides the type signature, I want to give to the code. PEX figured that out just by itself. So that's what PEX didn't do. Now what does PEX do? PEX really analyzes your code. So it looks at all the branches in the code, and then for each branching combination, it tries to come up with one input value that falls into this equivalence class for that branching combination. Then we use a constraint solver to come up with an input for that branching combination. So it's pretty sophisticated, but I don't go into the details now. And it analyzes your whole program, many functions at once, and it's looking at individual execution paths. So it's very precise. So as a result, you get a small test suite because PEX only emits a new test case to you if it increases coverage. You have seen that in the coverage graph. The white lines, you only get a new test case when it bumps up coverage. And the test suite has high code coverage because PEX looks at all the branches in the code. Okay, so to come to the end, what did you see? PEX can generate test suites with high code coverage, and the test suites often expose bugs because PEX considers each bug basically as a piece of code to cover all potential bugs. The generated test suites are fast running, so you can use them as build verification tests to detect breaking changes. They are regression test suites. The idea of parameterized unit test means that instead of writing many individual test cases, you can write general scenarios. So you write less test code, which means you have to maintain less test code. We have used PEX internally in Microsoft on already well-tested components, and components that have been tested for years, and we've still found new bugs. That's our general experience. Whenever we try out PEX on a new piece of code, it always finds some new bugs that people just didn't think about. And you can download PEX right now, try it out. It's a DevLabs project. That's the DevLabs website. And there's also a version for Visual Studio 2008 on a different license. Okay, so you have seen two tools in one talk.
Okay. Thank you. Please remember to fill out the evaluation for the session. We'd really like to hear your feedback. The whole reason we came down here was to talk to you, and so we'd like to know what you thought, and we're certainly open for questions. There's microphones along the aisles.
So academically, I mean, this problem with PEX, you've really done a great job. It's really impressive. Hard problem to solve. I do TDD, and so there are some things that I see about that I can see where, at least doing TDD, you could abuse this tool. And I'm wondering what your TDD story is with this tool.
I can answer that. So TDD is really about your approach to develop software. It's in your mind when you do TDD. Of course, you can abuse any technology, but you can also use it productively. So here the idea is that you write parameterized test cases. So often when you design your API and you write normal test cases, you have to pick particular values. Like you say, the name, you pick the name Peter if you put a value into a database, and then later in your test you verify that you got out Peter. But why this name? It doesn't matter. So whenever you have this situation that you don't care about a value, then when you design your API in TDD, just make it a parameter. It doesn't change the style of TDD. And then you can leverage PEX later on, once you have the code, to exploit and get high code coverage. I think they work perfectly together.
And then MS Test, did you have to use MS Test, or could you use a different testing framework?
PEX is extensible. There is support for also NUnit and MBUnit. And so go to our research website. There's a link to a Codeplex project where you can find as source code how to write these extensions so you can plug in your own framework too.
Very cool. Thank you.
Thanks. Maybe go over here next.
The contract library, will it also be available for linking against version 3.5?
So it's in your research download,
Yeah,
right?
in the research download, it comes as an independent library that you can use right now with 3.5. And then you won't need that any longer. Once you have 4.0, it'll just be inside the base class library.
The problem is it's only available if you are able to upgrade your project to version 4.0.
That's right. So, but the version that's available on the research download site has a separate contract library that you can link to.
But that's only the research license, right?
Unfortunately, it's only the research license.
Are there any plans to allow it for commercial use?
I don't know. We'd like to, but I'll have to go back and I'll bring that feedback back home.
Okay,
Thank you. Yeah.
I wanted to ask if the contract can be used to verify immutability on classes. And about PEX, I just wondered if you have used PEX to find bugs in PEX.
Okay, so yeah, I think being able to say that an object is immutable is very important, and we've done some initial work on that. The contracts can be used to express that. Usually you have to say that there's a phase change, right? So because an object normally goes through some period of mutability, and then at some point in time you freeze it. So you can introduce the idea of that there's this pre-frozen state, and then say that once it goes through this method, now it's in a frozen state. And then there can be guarantees that tell you that if it's in that frozen state, then you know that none of these values are changed.
So we did use PEX on itself, at least the managed portion. So PEX explores managed code, .NET code written in any language, but half of PEX is actually C++. It's a profiler to monitor the code. I didn't go into the details, but there's instrumentation going on. That part we cannot test with PEX, but the other part we do.
Okay, thank you.
What happens when you change the functionality of a class and you've got this set of libraries that PEX generated, and now you've changed something that would break those? What's the process of adapting over when you change a small piece of functionality?
So if you have generated test cases before, you can just rerun them to detect breaking changes, right? Is that what you mean? So
yeah, it would break those. Now, do you just...
So Visual Studio, the next version, comes with new features to detect which code changes relate to which test cases. So once you have the test suite generated yesterday, you can use that to pick the tests which are affected by your code changes to run them. So it's kind of independent of PEX, and you can definitely do it.
Okay, so but you could go in and modify the PEX test cases to for your new functionality, or
definitely.
Okay, and then when that's all satisfied, you could keep that test suite and then regenerate a new set of PEX?
So when you run PEX again, it would automatically detect which pieces, or so it would, some parts of the functionality probably didn't change. PEX wouldn't touch those test cases that it generated yesterday. But whatever did change, then PEX might delete some tests and emit new ones. So you see the difference in behavior also in which test cases get removed and which new ones are added, because old branches no longer exist and new branches need to be covered.
I guess my question would then be, how do you know that PEX is just not following changes that you're making that may be wrong? In other words, how do you reassert human control over it?
So to detect correctness, you need to write assertions, either in the code or in parameterized unit tests. And PEX will try to break them. So if you changed your code, PEX will try to break them with your new code. If you didn't write assertions, then PEX doesn't know either what correct means beyond not throwing exceptions.
Okay, thank you.
A question on PEX. If you have more complex data structures like nested collections and trees and things like that, will it generate test data that would go through and, at some level, 3 or 4 levels down, hit some condition and things like that?
So PEX can generate objects. So if you need a tree as an input where you need one object and the constructor needs another object, PEX would build a tree of objects. But again, so there comes a point when it doesn't scale anymore. So you can use it on a couple thousand lines of code, but if what you want to analyze, all the data structures are way beyond that, then PEX doesn't scale to that size.
Okay, so it's pretty much then kind of have to partition things out
Yes.
to build some tests that kind of test
Yes.
at a lower level maybe.
You should use PEX in a unit testing spirit. It can, so just as unit tests shouldn't be integration tests that test everything at once. You need to carve out a piece that you're interested in. And when you can do unit testing, you can use PEX.
All right, thank you.
You didn't demonstrate or show what the documentation looks like for the contracts.
Good point. So yeah, we currently do not have a tool that generates documentation for that. We're working with the team inside of Microsoft that already generates documentation from metadata inside managed assemblies, and we're working with them to define exactly how that will be surfaced.
So it won't be in the comments directly, it'll be after the fact in the XML.
Right. We think that the right way to do it would be to take the contracts and then generate the XML doc from it, but we haven't actually decided on the exact format of how that's going to look.
Thanks.
Yeah.
I assume it would be rather difficult to have PEX when it's generating unit tests based on parameters to be able to do those if those parameters are defined as interfaces. Do they have to be defined only as objects so that PEX can create them?
So when you want to run the tests that PEX generates, sooner or later you need some kind of object that can actually be created. And PEX comes with a stub framework that makes it easy to create stubs for arbitrary interfaces. And then PEX can create instances of these stubs when needed. So yeah, we need some kind of implementation, but PEX comes with a framework to generate them too.
Okay.
And so maybe normally when you're in this situation, you might write mock objects where you have to say, when this method is called, I return that value. And with PEX, all of that can also be parameterized. So instead of saying what values should be returned by all the functions, you can just make them test parameters. You can say, this interface is an arbitrary add-in. I don't care what it's doing. And then PEX will generate a stub that will return different things depending on what your program distinguishes. Okay.
Another question on the contract library. How is the how is the runtime checking performed, and how does it correlate when you use runtime type generation yourself in your project? For instance, I override all my properties. Sometimes I even suppress the base call. Is this a conflict with the runtime type generation U2?
Yeah, currently the runtime checking is performed as a post-build step. That's just takes the input assembly and generates a new assembly that then you execute against. So if you're doing dynamic loading or dynamic code generation, we currently don't have a way for you to say, well, now I've generated this method. Let me give it to the rewriter and have it do the right thing for adding contracts to that. But that's a good idea. We definitely should add hooks for that.
Okay, thank you.
Thanks.
How do you see the code contracts fitting into unit testing and test-driven development? I mean, if I have a contract for something, is it redundant that I would test the same functionality in a unit test? Because if I trust your tool and I'm going to get build warnings and errors, maybe I don't want to build tests for that anymore.
Right, so that's a great question. So we try to integrate with PEX. Well, I'll let Nikolai talk about that.
So contracts are good. Assertions are good. You should write as many as you can. But there are different kinds of them. So there are those which you can express within a function, because it's just relating to one function call. But if you want a contract that spans multiple calls, like I put this data into the database, I get it out again, you cannot write that as a contract. I mean, a contract requires or ensures, as we have seen. That's where you really, really need to write a test, a parameterized test, to express contracts that span method calls.
I think he's also asking, it's true, PEX can use contracts to filter out test cases that aren't needed because those test cases would violate a contract, and so they're not interesting inputs. Yeah.
If you annotate your function with a precondition, then PEX will not flag precondition violations as an error if you test that function. If another function uses it, it would be an error if you could trigger the precondition violation.
Okay, and then one other thing I was wondering about PEX, can you run an existing test suite that has pretty good coverage and then have PEX just generate tests for the missing gaps in the coverage?
So it's something we're working on, but today it doesn't pick up existing tests. It starts from scratch, future.
Okay.
So then I think we are out of time.
We're going to be at the lounge in the big room right after this talk, so we're certainly happy. Please come by, and we'd be happy to talk with you some more about that. Maybe take one last question or two?
One last question, okay.
Yes.
So you're determining that just by looking at the code and saying, well, this is pure, or is there some kind of new features explored on your end?
Right. So we've decoupled that. So so the question was about whether or not the methods, you can call methods in a contract, but they shouldn't change the state of the program. And that's a concept called method purity. It's a very complex problem to detect method purity. I'm happy to go into it in depth. So what we did was we decoupled it. What you have to do right now is you have to mark your methods as being pure using an attribute that comes along in the contract library. And right now, the onus is on you to live up to that marking. And we have separate tools that we're working on inside of research that can actually check method purity and guarantee that what you said is pure actually is pure.
So in theory, though, if I wasn't really pure, but I said it was, I could like hang your analysis.
Absolutely. You could definitely, it's not bulletproof yet. That's true. Thank you.
Okay.